Hey everyone, it's Gary here from Tipa. I'm going to be explaining more now about the range of compostable flexible packaging that Tipa offers, looking at some great applications globally where our materials are actually in use, and also looking into the composting process and the way that that waste stream would work for compostable flexible packaging. So if we first look at food packaging habits are coming back to haunt us. So what does this mean? Basically, traditional flexible packaging, so the OPPs, the polythenes, the polypropylenes that have been used for the last 30 or so years. Unfortunately, for us, they are just too resilient. They last too long. And unfortunately, that is meaning that they are washing up on beaches, they're being found in open land. And this is obviously terrible news for brands globally. So for them to find their brand in these environments is just not great for brand value, obviously. And it's not great for the planet, let's be honest. I think the other thing that's becoming more apparent is that consumers, the people that are actually buying these brands, are getting more disillusioned by the waste stream that exists today. So if we look at what's been happening to date, so approximately 9% of plastic so far have been recycled, which is a pretty low number, as we all know. Around 12% has been incinerated, and 79% has either been trapped in landfills or lost to the environment. So very much work in progress. If we look at the UK, around 50% of all the products that are in our supermarkets are actually packaged in flexible packaging. It is a runaway success, really, in terms of the pack format. It's lightweight, it does the right job for the product, it protects it, it gives us great shelf life. But unfortunately, once it's been used, it is very, very difficult to dispose of in the right way and recycle in the right way. The recycling rates for the UK are currently around 4%. So real work needed there to improve on that. We know there's a lot of work going on in this sector. But for Tipa, we were founded to find an alternative solution to this type of situation. So the business was founded on a compostable material that was bio-based that will provide a much simpler solution than traditional recycling, whether that be through mechanical or chemical recycling. So this is what we're trying to emulate, really, which is nature. So nature's done an amazing job, really, of protecting products over time. So there's some classic examples out of there, and this is just one of them. The outer packaging obviously protects the product. It gives it the right shelf life that's required. It's easy to open. It looks great. And most importantly, once it's done the job it's designed to do, it'll then return to nature in a timely fashion. And really, that's what the scientists of Tipa have emulated in the products that we offer. So Tipa's products are all designed by ourselves. So the formulations that we use are all Tipa patented. And they are all designed to replicate and replace conventional packaging in use. So if we look at the evolution of plastic end of life, you've got landfill. We've all been used to that for many, many years. Products are trapped in the ground, hopefully, and then stored there over time. This isn't a perfect practice either, as land is used up, and also landfills can breach. We're now seeing examples in the UK of landfills being broken by the sea erosion and content lost to the oceans, which is a terrible story. Then you look at recycling. So recycling is a downward spiral. By that, we mean you cannot indefinitely recycle products. Eventually, they start to lose their integrity and their durability. And eventually, you have to find another use for them at the end of that life, whether that be in landfill, maybe incineration, or really in very, very low-grade products. Composting, on the other hand, is a product that once used, you then put into the composting system. The materials are degraded then through that process, and they're returned to nature in the form of the compost, which is then used by the agricultural world to replace the lost topsoil. The compost that we put back on the soil adds carbon content to the soil, and they become the building blocks then for future plant life. So the soil then becomes very fertile and ideal for growing crops in the future. So a really important part of that circularity. So this is a great example of what we're supplying out into the market. So this is a stand-up pouch, as you can see. If this was a recycled or conventional packaging product, it would be very difficult to recycle. But for Tipa, this is a very simple product to compost. So we've engineered into this material everything that's required for this packaging to compost at the end of its useful life. But what we've also factored into the material is great barrier properties as well. So this particular pack has very good oxygen barrier and very good moisture barrier, so perfect for dried foods. It even has a zipper on there, which is our own formulation, which provides an easy open reclose facility. Again, a compostable zipper. So we've got very high functionality in the product. After use, once it's done its useful purpose in terms of transporting food, we can then return that to nature through the composting process. So here's a great example of our material in use. This is the Waitrose Duchy banana bag. So the bags are actually packed over in the plantations over in South America. So they effectively become the shipping bag as well. So it removed the requirement for shipping packaging. So once the bags arrive in the UK, they're ripened and then sold in the supermarkets. After use, the bag can then be disposed of through the composting process. Interestingly, Waitrose encourages their customers to use these bags as food caddy liners. So open your food caddy, pop the bag inside there, load that with food, and then when you're ready, the bag can then be put into the organic waste stream through food waste collection. This particular bag, though, I put into a home composting system. So as you can see, after approximately 45 days, I dug the bag out through the process and I had a look at it. And as you can see, the bag has transformed. It started to break down. So the first stage of composting is degradation. And this is where the bonds in our material are fragmented by the action of moisture. And that causes the material to break down and break up into small particles. After those particles break down, it moves on to digestion, which is where the bacteria and the microbes that live within the composting environment digest our material and transform it into CO2, water, and the compost or the biomass that we then use on the fields. So this is a shot here of some windrows. So Tipa has actively gone and approached the UK composting industry, and we work very closely with a number of them. This particular facility is Envar's over in Huntingdon. So what you're looking at here is the long windrows where the material is breaking down over time with the action of the organic microbes in that mass digesting and breaking down the material. So Envar is a facility that's the single largest site in the UK. It can process over 130,000 tonnes of material per year. They can and do already accept compostable packaging into this waste stream. They see it as an additional revenue source for those guys, and it is something that they endorse. They do ask that it is industrial compostable as a minimum, which obviously our materials are. So for us, this is a green light really to put our material into this type of facility. There's actually 53 composting facilities across the UK that are licensed to take food waste collection. So therefore, they could also process compostable packaging as part of their waste stream as well. So everything that needs to go into a facility, as I said, should be certified. So all of the materials that Tipa produce have a certification. So there's two classifications. One is home compostable, the other is industrial. Home composting, as it sounds, means that you can process that within the home environment through basically a bin within the garden. So a great first level, if you like, of waste management. The second level is industrial, and this is where we're working with people like Envar, which enables vast tonnages to be then processed in a very efficient way through their composting process. The compost that is generated by Envar is exceptionally valuable to the agricultural world. What's largely misunderstood or not known is that every year we're losing topsoil through farming and erosion. If we don't replace that topsoil, the fields around us become infertile, and we then become more and more reliant on adding artificial additives to the soil to boost it back. So what farmers like to do is to take compost, and they buy thousands of tons a year to replace that, that lost topsoil that they lose through the farming process. So we shouldn't undervalue compost really in terms of the agricultural world. It's also a fantastic means of sequestering carbon within the soil. So the CO2 and the carbon that was within the compost is then trapped within the soil and is a great sink then for the future for bringing down levels of CO2 and carbon in the environment. One of the things that we've also done this year is to get CRAE certification. This is an Irish certification. And what it means is that our materials have been tested in an industrial facility as finished pack formats. So it's the green light then for our materials to then go into Irish composters to ensure that our materials will be processed in a timely fashion for them. It's a really interesting process that they're developed in Ireland, and we wait to see whether or not that gets rolled out in other regions around the world. So this is an overview of the process that our materials go through. So as you can see, we start off with a resin. The resin, as I said earlier, is our own formulation and produced our own patents developed by the scientists over in Israel. We manufacture our materials on polythene extrusion lines. So for us, it was really important to generate a new material that ideally utilized existing equipment around the world. It made it very much easier to scale up as demand increases. So polythene extrusion lines is where it's produced. Chemistry is totally different, I will add, to polythene, but we utilize that equipment. Once we've then got the roll stock, it's designed to run on conventional flexo presses, laminators, and also through to conventional packaging machinery. So the material was designed to be as seamless as possible, integrating it into the existing infrastructure for materials. Once the products have then been used, we then go on to the composting phase, as you can see. So stage 1 is that degradation phase, as the material breaks down under the presence of moisture. Stage 2 is the digestion phase, which is where we break that material down to create the compost. And the circularity then comes from the compost being put back onto the fields to increase the carbon content in the soil to become then the building blocks for future plant life, bringing us the full circularity. So I've now got some fantastic examples for you of where our materials are actually in use globally. So this is down in South America for Bimbo. This is a bread bag. So it uses our home compostable material Tipa 302. So that's used, as you can see, for a wicketed bag. Then we have the Waitrose Duchy banana bags, as I've shown you already, some bags in action, so to speak, composting. So this is a brilliant application for our material. It's a nice, lightweight pack format, very, very durable, designed to transport those bananas over long distances and allow them to ripen as normal. And as I said earlier, once used, then return to nature in a timely fashion. Here we've got a more challenging application. So this is oats over in Holland. So this uses a laminate structure. So this particular product requires good moisture and good gas barrier. So this is a special product that we've developed that has the right criteria to do that. This particular bag is industrial compostable. We have just reformulated this material now. We've launched that actually around the 10th of November, that's been launched. And that's now a home compostable structure, which is a really exciting development for Tipa. The French market is very much going home compostable, as is other regions, and certainly the UK is a big fan of home compostable structures. So for us, a fantastic development. And as you can see, this particular pack is packaged on a vertical form fill packing line. So another important aspect for Tipa is that our materials don't slow down the packing process. So we have the right barrier properties to preserve the product, but also the right level of functionality to perform on packaging machines as conventional material does. Here we have an interesting product down in New Zealand. This is a home compostable pack for chickens. This uses our Tipa 302 material. Here we have a high barrier requirement for a T-type product. So this uses a high barrier triple laminate, a product that will be very difficult to recycle, but made from our compostable materials is a very simple product to compost after use. This is for tea. So again, products that need good gas, good moisture, and good light barrier. We can achieve that through adding different layers of materials together to build up the functionality that we need, and always with compostability as the end of life at the end of use. Here we've got some produce. So the characteristics of our monomaterials are that they have good, very high transmission rates to moisture and to gas. And that particularly is beneficial when you're packing products like salad, which during storage will give off moisture as part of that storage process. So that moisture vapor can pass through the surface of our material. And what it does is it actually helps prevent the buildup of condensation, moisture in the bag, which can trigger spoilage. An independent work that's been done using our material has proven that we can get shelf life extensions of up to 50% over conventional plastics. So don't believe that compostable materials automatically generates a loss of barrier. It can enhance the barrier and extend it further. And most importantly, then preventing food waste. Here's a lovely bag for apples down in New Zealand. So organic apples. Organic product, as we know, typically needs to be packaged to isolate it from cross-contamination from other products. So this is a nice home compostable solution. It has a zipper on there to make it easy open and reclose as well. So a very nice product there for New Zealand. And here's some of the brands that we're working with. So we are working with some fantastic retailers globally, as you can see. Some fantastic food brands as well. They're very much leading the market with their desire to move to bio-based and compostable. But we're not limited just to food. We have a large number of clothing brands, that also use Tipa's packaging to give bio-based and compostable solutions as well. So that's the end of the presentation in terms of what we do, how we do it. For us, the end of life really should be through an organic waste stream. It should be separate to recyclable plastics. So there should be a clear point where one material goes in the recycling direction. For us, for Tipa, our compostable packaging should go in that organic direction. That material could then be processed along with food waste and garden waste and then returned back into the compost that is so valuable to the agricultural world. It brings the circularity back to that process and really completes that circular story, if you like, of that compostable packaging being used. Thank you very much.